Okay, it is live now. Hello, everybody. And this is our second weekly hour. So it is the first time we do at around 10 p.m. And the professor is with us now.
All right. Thanks, Chow. Hello, everybody. This is our hangout for embedded software optimizations. As we promised last year, due to requests from many of you, we are trying to do it at 10 p.m. Eastern Standard Time because that way it will be in other parts of the world. We have many students from Korea, China, India, who are about 12 to 13 hours behind us, or sorry, ahead of us. And because of the time zone differences, this should be anywhere from 7:30 to 10 o'clock in Asia or 11 o'clock. So hope you are able to join this hangout. So I'll start with certain announcements and then we'll take questions. So first announcement is we have released our homework one, which is mainly on VLIW concepts, Amdahl's law, um, VEX instruction scheduling, and dependencies and very critical concepts which are involved in instruction scheduling and pipelining. This is a paper and pencil exercise. No implementation is involved in this particular homework. You are supposed to solve this just on paper and turn it in. Um, and the homework is due in 2 weeks, so we have given you enough time. And although it might run a little long in terms of description, it is not that scary. So there are three parts and different problems there. So mainly it is just description of the problem which is taking, but all you have to do is mainly many times scheduling or answer some questions. So it should be fairly straightforward, this particular homework. I hope you all have paced properly during the second week of classes now for OMS, and you are well doing well in terms of pacing and reading the background material and keeping up properly on the course because these homeworks and other things will be following as per the pacing schedule. So please do it. Please be on top of it, and please do also read the corresponding book chapters which are prescribed in the pacing schedule. Don't just watch the lesson videos, do both of these things. So that's this homework announcement. The second announcement is about Raspberry Pi. So we have put in the description of Raspberry Pi what to be bought and the OS and other things to be installed. And uh, excuse me, please go ahead and buy the system, the Raspberry Pi board, and do the needful and get it ready because soon we are going to assign you the project and you will be needing it for those purposes. And we don't want to be starting to buy these systems when the project is assigned. Sometimes they do go out of stock, sometimes it gets into delays to get back in on Amazon or wherever you are buying it from. And obviously we won't have time in this semester to give extensions because of any of these reasons. We have very tight ship to run this semester, and because of summer, which doesn't allow us to do any kind of adjustments on deadlines, due dates, will unfortunately be not be in a position to give any extension to anybody. So please go ahead and get these things right away once we have seen these kinds of announcements. If you have any questions, please do take advantage of Piazza and ask us. So we'll be moving forward on different topics. I hope again uh, we have also posted the errata about certain problems and errors in the lectures and in the videos, the quizzes. Please do consult those from time to time when you have any doubts. Hopefully, we have covered most of the errors that exist because we have accumulated this over a period of time, and hopefully that list of such things is now complete. Other than that, we don't have anything further. Both TAs are helping out in terms of monitoring, answering any questions on Piazza. If you have anything particular, please do again post it. I think in terms of many different things we'll be doing those soon once you have a good understanding of the architectural details, and we'll be proceeding in terms of trying to see how embedded processors are quite different than the normal processors, and you probably are starting to see some of these things as you are pacing through these videos. So I think those who are joining, I see some good number of students joining, so welcome all of you. I was just talking about not delaying buying the Raspberry Pi 3's boards, because we sometimes they do run or go out of stock, and then they take some time to get back in stock, and we won't have any time to give any extensions in case you don't have any boards. So please go ahead and order using the details that are provided, and get the OS and other things installed and test them out. And we have assigned the homework 1, which is due in 2 weeks. Do not worry about the length of the description of the homework. It just is a little verbose thing which explains a lot of interesting things. But mainly it is about simple concepts such as Amdahl's law, VLIW, pipelining, instruction scheduling, dependencies, and so on, registers, those kinds of things, which we'll be using these concepts as we go further in the class. So there are no other announcements at my point. Chao, you have anything to add?
No, that's it. I think in terms of the homework, I expected everybody could like handle something very clear, so it would make us easy to read the answers and to judge what happened. And if possible, please do like put as much details as possible in case there is something is wrong, so I can follow it. So what has happened, and we can capture the general ideas in your answers to give you some partial point. That is all.
Okay, great. So if any of you have any questions or anything, doubts, we can take those up now.
Okay. Actually,
Yes. Hello?
yeah.
Should we ask over audio, or would you rather we type the questions?
Of course, audio.
Okay, so this is Graham Arthur McKenzie. I'm just wondering, in regards to the project, I know the project hasn't been released yet, but what kinds of features should we be looking for in a teammate? And I'm speaking as somebody who, I think like many of my classmates, has virtually no experience with this subject matter. I think that a lot of us are in that boat, but I'm just kind of wondering, should I look for somebody with a lot of experience to balance it out, or are we all, should we find somebody who has a similar amount of experience to us? Thank you.
Okay. Usually, the way we have seen things work is you should be accessible to each other. Perhaps sometimes it helps to be in the same time zone in terms of trying to get as quickly as Skype call done, or discuss something or text messages, so that you don't have to wait for the next day, especially in a small development cycle. If you both are in the same time zone, that's certainly a big plus. You should definitely ask what kind of skills your partner has, and it will be good to have some kind of complementary skills. So for example, somebody has a good background in developing in C, C++, and debugging. The other person has a good background in terms of embedded systems, or some kind of embedded code, knowledge of how things look there, architectures. That's a nice complementary match. And in terms of somebody being more advanced than others, that always is the case. It's not ever a perfect match in terms of at this being same level. And most importantly, the two partners should have good agreement in terms of give and take. That, hey, if I will back you up in case you have a little bit of more work than I do, let's not worry too much about it. But you should sort of have a quick call and or exchange of email and see that how amicable you are with each other, and then try to pick from there. That's my suggestion.
Okay.
In terms of skill sets, I think most of you are at the same level. Some of you might definitely have an advantage because you worked in professional development environment. You might be doing some of this for your as a part of your job. If you have such expertise, then obviously your teammate is going to benefit from that. But that many, not maybe not that many students who are sort of quite advanced in terms of their development skills. So I think other factors take precedence in terms of um, being the same time zone, having a little bit of accommodation, uh, willingness to sort of help out each other, and certainly some kind of complementary skills. So
Okay,
those are
thank you.
some guidelines which you could follow, and take advantage of the Piazza, and post a small profile of what you know, what kind of time zone you are, things like that. You can make your own fields there and just post it, and then everybody can do the same, and um, pick who you think is a good person, and have a quick Skype call or a phone call, or just an email is sufficient.
Okay, thank you so much. And then just one follow-up question. Is it beneficial to be physically proximate to each other, or is that not necessarily helpful?
Not really, not really. I
Okay.
think you can use GitHub, and you can collaborate through GitHub repo. You can certainly even put some files in Google Drive and collaborate through that. If you're, of course, familiar with GitHub is versioning system, it's allows
Yes.
you to keep versions and then check in, check out, and nicely collaborate. And that way it works out very well. Physical proximity probably is not possible also because of I think most of you are probably all over different parts of the world, but
Right.
similar time zones definitely the plus.
Thank you very much.
Sure. Any other logistical or any other technical questions? Anything that we can help in terms of if you are facing some difficulties or any kind of thing? I guess it will start with the homework. We will obviously, we are just assigned it, so most of you probably hadn't had a chance to look at it, but we'll be monitoring Piazza and answering the questions through there. And I guess we have sufficient amount of time. As I said, it is not really a very involved long homework. I think it is quite nice to sort of have these concepts very clear in our mind, so it will set the stage for later parts of the class.
Okay, it seems we have no more questions from Piazza.
All right. So in the project we are going to look at, I'll talk a little bit about that, just to give some idea of what's forthcoming. We will investigate two concepts here. One is of speculation, and how much of speculation really helps, and what effects it has, and so on. That is one kind of thing. And it allows us to do better instruction scheduling, and it also has certain negative issues affiliated with the speculation, because of you're trying to go along a certain path of execution, and it may or may not be right, and so you have to kind of recover from it. That's one aspect. For performance, you do it. So those are misspeculation penalties, and something else which but it gives you more flexibility in terms of instruction schedule. We'll be looking at that. And the second part of the project will deal with um, um, trying to take advantage of mixed mode code generation on your most familiar processor, which is ARM. The ARM processor allows you to do 16 and 32-bit instruction generation and promotes code density. That is the number of useful bits in the instruction to the instruction width ratio of that, called as code density. Because of better code density, your power consumption, cache activity, all these things go down. That's why they have a mode called thumb. And then the full 32-bit mode is called as ARM. Of course, because of these, there comes restrictions in terms of execution efficiency because of the narrower width. And this type of thing exists across the board as a norm in embedded processors. By narrowing the instruction width, we are able to take advantage of more dense code and less in terms of the code size and cache activity and power and energy consumption. But we also pay a little bit in terms of performance. So this project will investigate these trade-offs between mixed code generation, which is part of the code will be in ARM and the other part will be in Thumb, and how to do this very efficiently, taking advantage of compiler support for that is sort of the topic of the project. Doing this inside a compiler is one of the most interesting things, but we obviously it is very, very complex, but we have ways to do it without changing the compiler, and we will try to investigate this trade-off and do certain measurements, and that's why we have these Raspberry Pi boards and other things. And I think those of you, so we are not going to really do energy meters here, but those of you who really have interest, they are not that expensive. They can put an energy meter and really see the energy consumption for mixed code versus the pure ARM or Thumb only code. And that is where really the trade-offs will show up in terms of lesser energy but similar performance. And energy consumption or battery life remains the premier criterion in mobile devices. And of course, the cost is another one, but we are not an industry, so we cannot really think in terms of that angle. But that is the reason why we have lesser amount of memories, some tighter restrictions, because we want to keep the resources tight and optimize under those conditions. I think both parts of the project will be interesting, and you will learn different things there. And I think having a good teammate certainly will help. And sometimes, unfortunately, things don't work the way they should. And if you're in that situation, as things progress, we would like to know about this. If you're running into any problems, we'll try to help you by reassigning you to another team if we can, or talking to your teammate in case of there are any issues, and taking things in the right direction for you. So please don't hesitate to talk to us. And TAs monitor the Piazza, so and they are well versed in terms of handling such issues. So we be assured that it will be easier if you want. Just send an email to both the TAs and copy me, so that I remain also in the loop in terms of such problems coming through. If in case of any emergencies about not being able to handle the homework because of personal emergency or anything, you can always shoot such an email to both the TAs and me. Of course, as I mentioned, we have a very tight ship here. Unless there's a real emergency and real reason, we of course will not be able to grant extension. It is not really in our hands. It is dictated by Georgia Tech policies. We'll be following those. But in case, of course, with back sickness or something happened, uh, we certainly will give you a little bit of extra time. Sorry. Chao, are there any other questions?
No.
Okay.
So do they need to build something like cross tool chains for the project? Or they do the development directly on the Raspberry Pi platform?
Sorry, Chao, you said something, asked something, or clarified something?
I'm interested in asking you something about the project. Do they need to build the cross tool chains on the host platform, or do the development on the Raspberry Pi system?
Oh, I see. So in terms of development environment.
Yeah.
So we typically give them a Vagrant build, which is a VM virtual machine, and they will install it on their host and do all the development there, because that's much easier on their desktop or laptop. And from there, they can download all the code and execute on the Raspberry Pi.
Oh, okay, I see.
Yeah, so that is the best way, because that way, in the desktop or laptop environment, they can use all the VM packages and resolve dependencies in terms of Linux and GCC and so on. So we'll be putting all these instructions, and we'll be doing that. We'll also be doing a homework, which is through the Vagrant, and we'll be packaging all the necessary tools there. Because there are typical GCC versions and all they have to use. So that will all be sitting inside a Vagrant environment.
Okay, and that would be much easier for them.
Yeah, yes. Because one of the things that we also do is sometimes give an account on our machines here at Georgia Tech, but their remote access is a very big problem. For them to SSH here, network connections sometimes are really bad. We'll go ahead and get them an account anyhow, and occasionally they can port things back up here, so that they can keep a repository or a copy here. So, but we have found out that these accounts sometimes are Deep Thought. We give them an account on a cluster called Deep Thought, but the connections out from those who are quite far from Georgia Tech, like Korea, China, India, and things like that, you will have very low latency, and you will get reset very frequently. Connections, the network connections are a big problem, and I think it's better to have a copy on your machine, develop it, and occasionally sync it back. So that is what we recommend. And there is one homework which is, of course, not based on Raspberry Pi. And for that also, we suggest the same development route, that you develop inside the Vagrant VM, do the solution, and then upload and test it back up on the Deep Thought. That way, your solution, because we will not be able to access your host to check your solution, but because of the VM, it doesn't matter where it is, it will work. And you should test it nevertheless before you turn it in on Deep Thought, that is the Georgia Tech machine. So that is a better route. Because for development, logging on Deep Thought, it will also throw you out, because there's too much load sometimes. These are the systems problems which probably are never going to get solved. So that's, yeah, but I'm glad you asked this question.
Hello.
Hello?
Hi. Yeah. I wanted to ask. My name is Jose Reyes. I think I emailed you when I wasn't able to open up the syllabuses, but I found the Canvas site and I got there. I wanted to ask, in your experience, which week or which topics turn out to be maybe requiring a little bit more work than other weeks or topics, just to get prepared?
Okay. It really, so it's really depends on your background in some ways. Um, um, but most students, this is my overall experience in the class, come from a computer architecture background. They may not have a software or a compiler background. And so for them, certain topics are very brand new, such as the register allocation topic. The second part of the class tends to be a little bit heavier. And the introductory topics are fine, but when they start reading papers, if they have not understood the foundation of why is the register allocation works the way it is, those lectures, why the control flow graph like this, but just because it's not difficult, but just because that they are coming from a slightly different background, which is more on the computer architecture side than the software system side. And some of the implementations things, they tend to be a little bit tricky for them. So that is something to watch out for. Trying to, when you paste those videos and when you try to read those papers are also a little bit heavy. They're about 30 pages, 25 to 30 to 40 pages sometimes. I think there's only one which is 35 pages, but the length is a wrong measure, of course, and don't get daunted by that. But some of the abstractions, like graphs, interference, traversals of those graphs, I think these are a little bit not, students are not typically exposed to these coming in unless they've done algorithms and those kinds of classes. So just be a little patient there and understand it a little slowly. You may want to do some background reading there in terms of graph traversals, very simple concepts of data structures and algorithms, and you should be fine from there. I think most of the topics in first half, they're fairly straightforward, they're fairly easy. And students coming from computer architecture background, they shouldn't have any problem. But the second half, a couple of topics are a little bit of a um, at least a hump in the road. So once you cross that and once you get those right, then the rest should also be smooth. Okay.
Okay. Thank you.
Sure. But nothing to be afraid of. This is not a class which is very heavy in terms of amount of work. It is also not heavy in terms of implementation, but it does need some systems and other skills, and quickly acquire those. And C++ programming, ability to work with GCC, other compilers, debug code, all that is of course expected. And pick it up. You have time. Pick it up and practice it a little bit. and I think you shouldn't be having any problem. And conceptually, as I said, only the initial part, second part is a little bit of a new material there.
This is Graham McKenzie again. Just another quick question. Sorry if I missed it, but is there a recommendation for resources to reference if we need to do some catching up with C, C++?
So the best book is, of course, the C, C++ books that are followed, that might have been followed in your undergraduate curriculum. Everybody follows different books. What we'll do is we will try to dig up the book that is followed typically at Georgia Tech, and we'll post that. Chow, off the top of your head, do you have any C, C++ book recommendation?
I think it for C is just the C programming language.
The Cunningham and Ritchie, right?
Yeah.
Or the Brian Strostrup book. Actually, those are the most standard books. The C is Cunningham and Ritchie, and C++ is John Strostrup. Those are the standard books. In addition, we'll check out if there is anybody. If any of you had any good book that you run into, please also go ahead and post it. But Cunningham and Ritchie is the most standard C book. And then, of course, Brian Strostrup is the C++.
Thank you very much.
Sure.
Yeah, this is Jose Reyes. I have a book that I can recommend. But is there going to be a lot of like object oriented that you're going to need to know, or is it just libraries that are C++ libraries that we're going to be using?
You won't run into, of course, huge code development here and deep object orientedness. You should certainly have knowledge and should arrange your code in classes and derived classes and overloading, and should have some fundamental knowledge of that, because it will make your job very easy to write the code in a reusable manner. But we are not dealing here with a very deep C++ or templated library oriented programming, or should I say programming which involves virtual functions. But some knowledge of class hierarchy, inheritance is needed, because those skills you will need as embedded programmers as you go further. It is simple C++, not deep C++ that is used, because more complex it gets, it also costs you a lot in terms of the runtime overheads. Because the C++ code, once it is compiled by the compiler, if it's complex, it has a lot of runtime overheads. So that is not this kind of C++ which is encouraged as an embedded C++ programming practice. At the same time, this is an age in which we are doing a lot of software reuse and team development and organizing your code in terms of objects, classes, inheritance, overloading, things like that. You should definitely use those features, which are not really very complex. So medium level C++, I would say, not really deep. Okay.
Okay, thank you. So I have another question about the second part. You said in the compilers that we would have to recognize, was it path traversal or?
No, graph traversal. So
graph
mostly you'll be using graph as an abstraction, directed cyclic or acyclic graph. When there is a node, there are nodes which are connected by directed edges, and the graph is traversed in a particular order, and so on. Concepts of traversing the graph and so on. That is what I was talking about.
Okay. Will we need to write like algorithms that do that, or?
In the small part of the project does need some of those algorithms to be written, and also the papers have algorithms. They're not difficult. They are pretty self-explanatory in terms of how they do and so on. But having some knowledge of some graph algorithms for directed and acyclic graphs or undirected graphs will certainly be helpful to understand the concept, because this topic, if you've done data structures and algorithms type of a class or data structures class, you should be just fine. Some students haven't done that, because especially those who come from a little bit of electrical engineering backgrounds may not have seen some of these things. So on the internet, there are plenty of these simple, even YouTube videos and all, to show graph traversal. So you should not have any difficulty in just watching some of that and also picking it up.
Okay. Yeah, great. That's good to know. So I can review the
Yeah. So there are simple concepts like of course, all of us know what is depth first, breadth first, traversals, and all that. But what is a bipartite graph, for example? Then what is exactly a graph cover, in an undirected graph cover? So those kind of concepts. There are simple illustrations of how to find maximum weighted path cover, for example. These are some of these things. You will run into those papers, and when you run into those, if you're not done the CS type of class, you can go to the YouTube and pick up some of the nice videos on these topics, or even some simple illustrations. If they're not on YouTube, find some very simple, even Wikipedia pages and all that, which are quite sufficient to gain a high level understanding. And then the paper itself will cover the algorithm. So you have to then follow the notation, and I think it's not difficult.
Okay. All right. Thank you. Yeah. I think I remember one of them being that you needed to keep track of all the nodes that you had visited, so that you.
Yes. So that you don't form a cycle again by visiting them.
Yeah.
So that it is a directed, so that it's a cyclic path. Things like that.
Awesome. Well, yeah, I'm excited now.
Good. Yeah, I mentioned this just to help out rather than to scare anybody. So no need to be scared. If anybody is slightly deficient in it, it's very easy to pick it up.
Okay. And for the vex commands, I see that the first book we have has an appendix that goes through the language, like a reference. Are we gonna be going like deep into vex, or just overall?
Not really. So one of the exercises is we're going to use the vex compiled simulated programs and do some small exercises there, and There is a VEX reference manual, which is what you mentioned. It gives you general overview and what are the restrictions on the VEX instruction, how the bundling occurs, and so on. And we are going to gain some insight into the VLIW side of VEX, but we are not really. What we are not really doing here is we are not really devising a compiler for VEX because that's obviously a huge undertaking. But we'll learn about certain interesting characteristics, how the VEX conventions are, what the syntax means, what the bundling means, what all kinds of different things. And we'll do some simple exercises to maybe schedule a VEX program or do something with that we can compact it more, things like that. We will be giving you some kind of a tool, or we'll be giving you some kind of a utility function, which will, as what we call it, a post-pass, post-assembly, some small things on that generated assembly to optimize it in terms of the size or in terms of efficiency or schedule. Because that way it gives us an independence. Of course, the VEX compiler itself is not open source, and there is, unless we develop our own, we cannot deal with it. But there are a lot of things which we can do post-pass, and we'll be giving you small to be able to deal with it. So imagine that you have an assembly, and we give you a small tool to, take this assembly and do something with it, and how you can write your own C++ programs which can optimize the generated assembly. That's basically some kind of a simple exercise. Okay, so that is the extent to which you have to then refer to the VEX instructions to figure out what the conventions are, because when you're reorganizing the code, you cannot generate certain code which is in violation of the VEX assembler. But finally, it will go through the assembler and generate the executable. So those kinds of things we will be just talking about. So
Okay.
it will be interesting. So it will give you a little bit of exposure in terms of how to deal with something when you don't have tools which are closed source to deal with some things, but still get around those, use utilities, rearrange assembly. So there are a lot of optimizers which are binary to binary or post-code generation optimization, and we'll be dealing with some of those. So very simple projects.
All right. Yeah. Thank you. Thank you.
Sure. Okay. I guess we are headed towards the end. It's also getting late here on the East Coast. We can probably be done now for today, unless there are other questions. Or Chow, you have anything else to ask from Piazza or anything? And of course, resume it again next week and in between if you have anything. So please do get in touch. Is Chow anything else there?
No, there is nothing.
Okay. Well, I really want to thank those who came on board today, and I hope this time is working out for all of you. And good to talk to you. And I hope I didn't inconvenience anybody because of the time zones this time. If I did, those who are in Europe probably might be the one who might be at 4 a.m. right now. But I don't know how to deal with that. So if you really want me to do one more of change, then let to rethink in terms of timing. I don't know if there is any good time for everybody here, but thank you for your participation, and good night from here for now. We have a Memorial Day here, which is a longer weekend. On Monday, we have a holiday. So those of you who are in US or wherever you have holidays, have a great Memorial Day, and we'll see you next week. At the same time, if you have any concerns of still about timing, please email me and the TAs, and we will see if we can still adjust it and fine tune it. I hope you are able to join and talk to us. That is our goal. And thank you again, and good night from here.
Thank you.
Okay, bye-bye.
Bye.
Bye.
Thank you. Good night.
Good
Good
night.
night. Yes. Yeah.